Question 7. After a college's football team once again lost a football game to the arch rival, the Alumni Association decided to conduct a survey to see if alumni were in favor of firing the coach. Let P represent the proportion of all living alumni who favor firing the coach. Which of the following is the smallest sample size needed to guarantee an estimate that's within 0.05 of P at a 95% confidence level? All right, so this 0.05, that's the margin of error. 95%, that's the confidence level. Okay, so that is associated with this critical value right here, 1.960. 1.96. All right, and we want to figure out the sample size. Okay. All right, so since they talk about a margin of error, let's just start with that formula. Okay, so the margin of error is equal to the critical value times the standard error. Okay. So the critical value is that special z-score, and the standard error, if we're estimating a proportion, let's flip back to the formula sheet here, the standard error right here. All right, so that's the standard error for estimating a proportion. Square root p hat 1 minus p hat over n. Okay, so we have a value to substitute there. This is what we're trying to solve for. Okay. Nowhere in the problem does it give us a point estimate, right? We don't know what proportion of a sample is in favor of firing the coach. So in a situation like this, we're just going to default to 0.5, right? Which is like right in the middle. Okay. We also know that we have a value to plug in there. All right, so we're going to use p hat 0.5. All right, so let's plug in the numbers and see what we get. 0.05 equals 1.96 times the square root of 0.5 times 0.5 over n. All right, so there's a lot of different ways that you can solve this. I think probably one of the quickest methods is to, number one, separate this square root into 2. Okay, so instead of one root over the whole fraction, you have a root in the numerator and in the denominator. Okay. Right, now we can multiply both sides by root n, and then at the same time we can divide both sides by 0.05. Okay, so the root n's are going to cancel on the right, the 0.05s are going to cancel on the left. Okay, so now we've got root n equals 1.96 over 0.05 times the square root of 0.5 times 0.5. Okay. And then we'll square both sides. Yeah. Forgot to write the square there. All right, so square and the root cancel each other out, so now we've got n equals, and then here we can essentially just distribute the power to all three factors there. So get 1.96 squared, 0.05 squared, and then the power and the root cancel each other out, so you just have 0.5 times 0.5 now. All right, and then let's go ahead and type that into the calculator. 1.96 squared, 0.05 squared times 0.5 times 0.5 gives 384.16. Okay, so let's look at our answer choices. Yeah, we're going to go with B. Now remember, when you're calculating a sample size, or talking about sampling alumni, which are people, yes, you can sample 384 people. You cannot sample 16% of a person or 1600ths of a person. You'd have to sample that whole person. So normally when we get a decimal value like this, we always want to round up, right? Even though 385 is the closest whole number, right? This is saying that, you need a little bit more than 384, so just grab the whole next person, 385.